Excavators discover artifacts and antiquities through excavation. Buried in soil, these remains can endure for millennia, but upon exposure, conservation and preservation become critical. To reconstruct history accurately, artifacts must retain their original form. Soil moisture, acidity, alkalinity, and pressure affect buried objects, while post-exposure risks include environmental factors and maintenance challenges. Cleaning methods vary. Stone sculptures require simple water washing, whereas iron, copper, bronze, bone, ivory, silver, and gold objects need chemical treatments. A chemist or field laboratory near the site is essential. Fragile materials like wood, ivory, textiles, leather, and paper demand extreme caution due to their age-related fragility. Essential chemicals include nitric acid, citric acid, sulfuric acid, acetic acid, hydrochloric acid, polyvinyl acetate, silver nitrate, shellac, bedacryl 122X-toluene, acetone, ammonia, and caustic soda. Equipment like test tubes, brushes, heat-resistant wire, sandpaper, wax, and plaster of Paris are vital. Salt-free water is paramount for repeated use. Key processes involve chemical cleaning, moisture control, and environmental protection. Wheeler emphasized the need for an archaeological chemist and field laboratory for friable materials. Documentation of all treatments and immediate post-exposure protection are mandatory to prevent deterioration. Different methods and chemicals are used for cleaning, conserving, and preserving artifacts made from various materials, the details of which are as follows. Stone-made objects including sculptures, tools, vessels, and pillars are vital antiquities. Cleaning methods vary by stone type. Sandstone, which absorbs salt, requires paper pulp application. Soak paper, beat into pulp, apply a 2 to 3 centimeter layer, and repeat until salt removal is confirmed via a silver nitrate test. Soapstone, limestone, and marble absorb soil acids and are cleaned with calcium sulfate solutions or plaster of Paris-treated water. This involves letting plaster settle in water, then decanting for use. Post-cleaning, artifacts are washed and dried. Clay-made objects, including pots, sculptures, seals, and painted tablets, constitute a significant portion of archaeological finds. Baked clay remains fragile, while unbaked clay is highly susceptible to damage, necessitating extreme caution during cleaning and handling. These objects absorb salt and alkalis from soil, requiring salt-free water for washing. Silver nitrate tests confirm salt removal. Milky water indicates residual salt, necessitating repeated washing until clear. For alkali detection, barium chloride produces a white precipitate. Painted designs are protected with a 5% vinyl acetate coating, followed by thorough drying in shade to prevent cracking. Clay seals and tablets are archaeologically critical, offering insights into ancient political, economic, and cultural systems. Mesopotamian seals were strengthened by firing in metal boxes layered with sand, though this altered their color. Early neglect caused damage to inscribed tablets, but later recognition led to improved preservation practices. Fragile clay artifacts often require rejoining broken pieces. Gum lac, shellac, or vinyl acetate resin dissolved in spirit are traditional adhesives. Modern adhesives provide instant, mark-free bonding. Broken edges must be meticulously cleaned before application to ensure structural integrity. Gold objects regain luster through wiping or mild detergents. Hydrochloric acid addresses stubborn stains. Silver artifacts with silver chloride layers require 3% sulfuric acid or ammonia solutions. Verify silver content before cleaning to prevent damage and store in sulfur-free environments. Iron artifacts prone to rust need immediate drying post-excavation. Sodium carbonate solutions at 20% stabilize waterlogged items, while zinc sheets or distilled water boiling removes chlorides. Use magnets to confirm iron content and stabilize fragile pieces with paraffin wax or plaster of Paris. Coin cleaning employs electrochemical reduction. Attach coins to a battery's negative terminal in a 2% caustic soda solution with a graphite anode. Replace the battery every 24 to 48 hours. Rinse the coins with distilled water and coat them with betacryl or polyvinyl acetate. The copper artifacts are cleaned with a mixture of tartaric acid and caustic soda solutions in a 1:1:10 ratio to dissolve the green patina. For red oxide, use a combination of citric acid and sulfuric acid, followed by an ammonia rinse. Finally, coat the artifacts with polyvinyl acetate to protect them. Lead artifacts degrade easily. A 20% caustic soda solution combined with sulfur is used to remove corrosion. Rinse the artifacts with warm water and apply a vinyl acetate coating. Glass artifacts require mechanical cleaning with pins or knives to remove salts. Strengthen with polyvinyl acetate or bava and photograph before handling to document original color. Chemical disodium EDIA gels 2 to 5% for silver-plated copper, sodium hydroxide for iron. Laser ENYAG and TCO2 lasers remove corrosion without damaging surfaces. Mechanical ultrasonic tools and stencil brushes clean stable metals. X-radiography assesses internal corrosion. Protective coatings, paraffin beeswax mixtures or acrylic sprays prevent moisture damage. Bone and ivory artifacts, often well preserved in dry climates, require meticulous handling due to their susceptibility to moisture and environmental stress. Post-excavation, assess water sensitivity. Washing with clean water using wooden or plastic brushes avoids scratches. For insoluble salts, a 15% acetic acid solution is recommended, while nitrate or hydrochloric acid must be avoided to prevent dissolution. Strengthen fragile items with polyvinyl acetate coatings or betacryl 227 or binomul pre-lifting. Ivory objects like combs, mirror handles and cosmetic tools demand immediate shaded drying post-excavation. Use soft brushes for dirt removal and employ soluble nylon to extract salts, followed by distilled water rinses, 4 to 5 cycles, and alcohol or ether drying within 30 minutes. Plaster of Paris can reinforce structural integrity when necessary. Preventive measures include maintaining a stable temperature at or below 25 degrees Celsius and humidity between 45 and 55% relative humidity during storage or display. It's crucial to avoid direct light and acidic materials. For transport, wrap the artifacts in acid-free tissue, seal them in polyethylene bags, and cushion with bubble wrap to buffer environmental shifts. Perishable materials like paper, birch bark, cloth and wood are highly susceptible to damage from moisture and environmental exposure. Paper and cloth are cleaned by sandwiching them between blotting paper to absorb salts, followed by gentle brushing and shade drying. Birch bark requires steaming over boiling water for 2 to 3 minutes, pressing between blotting paper and applying a 10% vinyl acetate solution for preservation. Wooden objects prone to crumbling post-excavation are stabilized using wood shavings, moss or newspaper to buffer environmental shifts. Glycerin mixed with 10% polyvinyl acetate or alcohol preserves moisture, while paper pulp removes absorbed salts. Celery extract or coal smoke combats termites. A final 10% polyvinyl acetate coating strengthens the wood, but rapid laboratory transfer is critical. Effective preservation demands material-specific techniques. Salinity control. Use blotting paper or paper pulp for salt removal. Structural reinforcement, vinyl acetate or polyvinyl coatings prevent disintegration. Documentation labeling artifacts with origin and context avoids post-cleaning confusion. Ruins require ongoing care to maintain their integrity. This includes removing vegetation and repositioning bricks that have been displaced by rain. At coastal sites like Mahabalipuram, salt layers are eliminated using pressure washing. Cracks in structures are repaired through pressure grouting and underpinning of damaged bricks. Fallen structures are reconstructed using historical photographs and original materials such as matching sand or cement. Tree root removal and grass clearance are carried out to mitigate biological threats. Natural disasters such as earthquakes and human activities such as construction require compensatory measures including legal safeguards and community awareness programs. Effective conservation and preservation of artifacts, whether stone, clay, metal or organic materials, demand material-specific strategies and expertise. Chemical treatments, environmental controls, and advanced techniques ensure both structural and aesthetic integrity. Preventive measures like salt removal, protective coatings, and proper storage reduce post-excavation risks. Site preservation and reconstruction using historical records safeguard monuments. Addressing challenges such as natural disasters and human activities requires legal frameworks and community engagement. Ultimately, meticulous documentation, specialized laboratories, and interdisciplinary collaboration are essential to preserve cultural heritage for future generations.